Describing the motion of an object is occasionally hard to do with words. Sometimes graphs help make motion easier to picture and therefore understand. To do this, you need to remember that motion is a change in position measured by distance and time. Speed tells us the rate at which an object moves. Velocity is the speed and direction of a moving object, and acceleration tells us the rate, speed, or direction changes. So we're going to look at distance-time graphs first. Plotting distance against time can tell you a lot about motion. Let's look at the axes. We have distance on the y-axis and time on the x-axis. The motion of the object in this graph is moving at a constant speed away from start. 0, 0 is always your origin or your starting point. Just like yesterday when you were graphing the movement of the marble on the track. You started at 0 and you moved out most of the time to 130 because that was the length of the track. It looks like a straight line with a positive slope. This object is moving back towards start. So this could be, for example, you leaving school and going back home. So it's a straight line with a negative slope. In this graph, we have a flat line. That means that the time is staying the same. The time is changing, but the distance is staying the same. So the object is at rest. It's not moving. Its distance, its position stays the same the entire time. So in this one, we're going to have 3 objects that are moving away from the start at a constant speed, but all have different speeds. So this will be like yesterday, you graphed 2 different lines, one for the metal marble and one for the plastic marble on the same graph. So you showed the different speeds, and most of the time the metal one had a steeper slope. So we get straight lines with positive slopes. They're all different, and remember that the steeper slope is the faster speed. For this one, we have an object that moves 18 meters in 6 seconds at a constant speed away from start, but then returns to start at the same constant speed. So it's a straight line with a positive slope, then the straight line with a negative slope. So the lines have the same steepness, so they're going the same speed. Here the object is speeding up and moving away from start. So this one shows acceleration. We're seeing a change in the speed, an upward curved line. For this one, we have an object that is slowing down, moving away from start. So it's an upward curved line, and it begins as an almost vertical line, meaning it was going very quickly, and then it quickly decreases in steepness to an almost horizontal line. So if you see the curved lines, you know there's some acceleration, there's some change in speed going on. Here we have an object that speeds up while returning to start. So the line is downwardly curved, and it begins as an almost horizontal line, which means, that's stationary. It's not moving very fast. The time is going on, but distance isn't changing very much, and then it quickly increases in steepness. Here, the object slows down while returning to start. We have a downward curved line that begins as an almost vertical line, then quickly decreases in steepness. So it's slowing down as it goes back home. And then finally, we have an object that takes 3 seconds to travel 22 meters away from start at a constant speed. After stopping for a 2-second rest, it slowly returns to start at a constant speed, taking 7 seconds to travel 6 meters. So it's heading back towards home, but it doesn't go all the way home. So it's a straight line with a steep positive slope, a horizontal line, and then a straight line with a low negative slope. Try not to fall into the trap. A lot of kids look at these and they think this means uphill or downhill. Get that out of your head. That's not what that means. It's got to do with the distance traveled. So some things to remember. A horizontal line means the object is at rest. A straight line with the slope positive or negative means the object is moving at a constant speed. A line with a positive slope means the object is moving away from the start. A line with a negative slope means the object is moving toward the start. And a curved line means the object is accelerating, which in science could mean speeding up or slowing down. Also, a line with a steep or higher slope means that the object is moving at a fast speed, and a line with a gentle or lower slope means the object is moving at a slow speed. A line that changes from positive to negative or vice versa means that the object is changing directions. So here we're going to switch over to speed time graphs, which are also sometimes called velocity time graphs. They work the exact same way. Speed time graphs look a lot like your distance time graphs, but you need to make sure you're reading the labels. On the speed time graph, time is plotted on the x-axis. Speed or velocity is plotted on the y-axis. A straight horizontal line on a speed time graph means speed is constant. It is not changing over time. Straight lines do not mean that the object is stationary. So here we have a straight line. The object is moving at a constant high speed. The speed of that object is about 32 meters per second. So it's moving at that constant higher speed because it's higher up on the graph. You know, it's going at one of the top speeds that they were graphed. This one, the object is moving at a constant low speed. So we have a horizontal line lower on the graph. And then this one, in order to show at rest, that line is going to have to be down here on the x-axis. That is what's at rest on a speed time or velocity time graph. Here we have an object that is slowing down at a constant rate. So we're going to have a straight line with a negative slope. Because if we look at this, you can see that the speed, for each second, the speed is getting lower and lower and lower. So we have a straight line, negative slope. On our next one, we have an object that is speeding up at a constant rate. So every second, the speed is higher and higher at a constant rate. For this one, we have two objects speeding up at a constant rate. One has a greater acceleration than the other. Straight lines with positive slopes. Lines have different slopes. The steeper slope means greater acceleration. Then here we have an object that is gradually slowing down. The line is going to curve downward until it is nearly horizontal. And here we have an object that gradually speeds up with the line curving upward, nearing vertical. So here is a scenario. Bus at a bus stop for 3 seconds. It then accelerates at a constant rate toward the next stop. Then the speed of the bus changes from 0 to 10 meters per second in 4 seconds. So as the bus gets closer to the next stop, it gradually slows down from 10 to 0 in 4 seconds. So we would describe the line as a horizontal line on the x-axis, meaning it was at rest, a straight line with a positive slope, and then a line curving downward to show it's slowing down. Our facts to remember about speed time: horizontal line above the x-axis means the object is moving at a constant speed. Horizontal lines on the x-axis mean at rest. That's the only way we can get at rest on a speed time graph, because the speed has to be 0. A straight line with a positive slope means the object is speeding up with steady or constant acceleration. And a straight line with a negative slope means the object is slowing down with steady, constant acceleration. Also, a line curving downward means the object is gradually slowing down. A line curving upward means the object is gradually speeding up. A line with a steep or higher slope means the object is accelerating at a higher rate, or faster rate, excuse me. A line with a gentle or lower slope means that the object is accelerating at a slower rate. And here kind of to see all of the lines on, or some of the lines on the same graph here. So the steeper the graph, the greater the acceleration. Horizontal means the object is moving at a constant speed, and downward sloping means the object is slowing down.